Hi, this is Mrs. Boykin. We're going to talk about parent graphs and discussing the intervals of increasing and decreasing on our parent graph. Intervals of increasing and decreasing are referring to the x values only on our graph. Never do we refer to what value on y is the graph increasing or decreasing. It only pertains to the x values. So increasing, it's basically asking us where on the x-axis does our graph begin to increase? Where does it stop increasing? Intervals of decreasing, we look on the x-axis. Where does the graph begin to decrease? What x value did it start to decrease? And where on the x value did it stop? So let's take a look at some graphs. Here's a graph of our quadratic. And if I were to read my graph, don't forget we have to read it from left to right. If I begin on the left-hand side and I'm going to talk about decreasing, I'm going to highlight that in blue. So basically, if I can follow this path, I am decreasing until I get to this ordered pair right here. So we're going to just describe that. Okay, so where did it decrease? Well, as I know that we're talking about x values, here it's about 2.5, it's 2, it's 1, it's just going to keep on going forever to the side. Basically, as I'm traveling up, I'm also traveling to the left. So I would write my interval that it is decreasing from x of negative infinity, and it stopped at, we'll call that 2.5. At the x value of 2.5, it neither increased nor it decreased. So we don't want to include that. So that's why we don't have the underlined portion of our inequality symbol. So, and then from this point forward, this is where the graph increased. And so we can see that on the increase, it started at 2.5. And then it continued, as we can see, that as this is going up, it's moving farther to the left. It's going to 3, 4, 5, 6, if we keep drawing down. And it stopped at positive infinity. This is our interval notation, and we have discussed the areas where it decreased and the areas that it increased. We know with other polynomials, sometimes there can be more than one area where it decreased and more than one area where it increased, depending how many turning points. And this portion right here is considered the turning point, the point where it stopped decreasing and then began to increase. Let's look at some other parent graphs. Here's our exponential. I'm using the same graphs as I did for and behavior. And here, again, I gotta go from left to right on my graph. So on the left, this pretty much looks like it's hovering pretty horizontally. But never did it decrease. It is only increasing. So you may think that it's the value maintained the same, but it became ever so close to 0 that technically even 10 decimal places out, it starts to increase. So the entire interval on x on the left-hand side going to negative infinity on the x, as we go forward, it's done nothing but increase, and as we move up, we are technically moving farther to the right. So our interval of x is going from negative infinity to positive infinity, and it only increased. It never decreased. This is our interval of increasing. Let's take a look at our next graph. And so we're looking here on the x, and where did it start increasing on the x? Well, if you remember from my last discussion, we have a vertical asymptote. And our graph will never cross that vertical asymptote. It comes very close to equaling -1, but never quite equaling -1. So we can say our graph is increasing, starting at the x value of -1, but never equaling that. And as we move up our graph and further to the right, we are doing nothing but increasing as we move along the x-axis. as we go to 6, 7, 8, 10, it will always be increasing. So that's increasing from -1 all the way to positive infinity. Let's look at our next graph, and this is our square root function. And as we start the graph on the left, we notice that we are doing just the same. We're doing nothing but increasing. But the question is, where did it start increasing? And so we're reading our graph again, paying attention only to x values. It started at a -3. And then it continued increasing as the graph moves to the right. On the x-axis, it just goes to positive infinity. So this graph was doing nothing but increasing. And if I were to go to my next graph, which I don't have one, but we're going to draw one. And let's just say that this graph, and probably I'm going to redo this one. I want to draw it in black so I can label in red and blue increasing, decreasing. So let's draw the graph. And let's talk about the areas that it increased. Well, it's increasing here until it reached this point, then it starts to decrease. And just because it hit the x-axis does not mean it stopped decreasing. And then it took over and it's increasing again. So again, I'm not even going to label the x-axis because it doesn't matter. But this point here, if we follow it down to the x-axis, let's call this a -3. And let's call this +3. So let's talk about our intervals. It's increasing. Again, if we follow this as we go down the graph, I know it's going down, but we are increasing because we do need to start at this point. But we can see the graph is moving further to the left. So starting on the left, it's increasing until it got to -3. And now it's increasing beginning at the +3. And as it increased, it did move farther to the right to positive infinity. So those were our two intervals of increasing. Decreasing, the graph began to decrease at -3, and it stopped decreasing when we reached the +3. So when you're reading a graph, try to disregard the fact that you have an a y-axis there, and just think about the movements along the x-axis. So if we were basically to get rid of this, to get your focus just around those x values only, then maybe you would have an easier time of talking about where on the x-axis did something increase or decrease. Well, that's it for now. I hope you don't have any difficulty in filling in the back of your parent graph sheet where I asked you to do intervals of increasing and decreasing for homework, and also the end behavior pertaining to those 10 parent graph functions that I assigned. Anyways, I hope to see you next week, and I think we've had enough of the snow. This is Miss Boykin signing off.